Saxon's Calculus Lesson 25. Sums, products, and quotients of functions, and then composition of functions. So we jump right into example 1, and they tell us that we have an f of x whose equation is x squared and a g of x whose equation is the square root of x. And then in A, B, C, and D, they basically ask us to solve for adding the functions, subtracting the functions, multiplying the functions, and dividing the functions, and what do I get for these specific examples. So if you remember, what we do is we take the two equations and we follow whatever this says. So we add. Since x squared plus the square root of x are not like terms, that's as far as I can take it. Same thing with the minus. X squared minus the square root of x, because the f came first, I'm writing its formula first. Now when it comes to the multiply, doesn't matter which one I write first because order doesn't matter when I'm multiplying, but x squared then multiply with root x. I might leave it that way. However, if I put it in its exponent format, this is x squared and this is x to the 1/2, because remember the exponent is whatever it is the numerator, that's an implied 1, and the root number is the denominator in a square root, that's an implied 2. Bases that are multiplying, exponents are added. So this needs a common denominator of 2, which turns it into 4. 4 plus 1 then is 5/2. So this is the same as x to the 5/2. And that's an acceptable answer. I was double checking there. Then the minus one, we know that the divide one, oh my goodness, that's going to be x squared divided by square root of x. Now I can't have that square root of x in the bottom, so I multiply by square root of x to balance it. This puts it as x squared, x to the 1/2, I'm just going to go ahead and put it in that same format, over top of x. And then this x that's in the denominator, if I move it up, I make it x to the -1. Now it's gone from here. So x squared and x -1 makes x to the first, adding with x to the 1/2, so that's 1.5, improper, that's 3/2. So x to the 3/2 will work as the simplification for the division. Now, oh, and it says, so find the answers and then include the domain for each. Okay, I was not writing the domain as we did these. So it's asking, is there a limitation to the kind of numbers that I'm allowed to plug into this problem? Well, yes, there's no problem with squaring something, but this one can't have negatives. So, and of course a set notation, x is an element of the reals such that, and x has to be greater than or equal to 0, end of that one, because I can't have negatives in the root. Now I have the same thing here with this one, even though it's minusing, but this would be the same domain, I'm still limited. And then what happens here when I have to the 5/2? That implied a root. And I'm picturing if I have a positive and I take it to the 5th power, that's still a positive. But if I were plugging in a negative, I would, oh no, those are my ranges. I don't need to care about what's coming out. I just have to make sure that what I'm plugging in does not create the negative. That's the same limitation. On the 3/2, I can't include the 0. So its domain is going to change to x is an element of the reals such that x is greater than 0. And you might have been asking, how did I get that distinction that it couldn't be 0? Because when I started originally, and I didn't write it, I had x, oh yes I did, right here, I had x squared over this. I can't have a 0 in the denominator, even though it can simplify to this at the end. In its original form, 0 can't be in the bottom, so I can't have the or equal to 0. Then in part B, we're doing compositions. And hopefully you remember from trig class that that is things that use the circle. So like f of g, it looks like fog, but that little circle symbol isn't trying to make the word fog, it's giving you the indication that it wants a composition. So it means to pick up G's formula and plug it into F's formula. That's what combination or composition of functions means. Now, example 2 says use f of x equals x squared plus 2 and g of x equals 3x plus 5 to form the composite function for, and they want f of g of x. So again, it's exactly as I said, we need to pick up g's equation and put it into f's because g's came second, it goes into the other. So here, everywhere I had an x, I'm going to plug in g. So it's that squared, and then the plus 2 is still there. So 3x plus 5 gets filled in. And then I would need to work that out to its simplified form, or are they going to let me leave it? Oh, they're going to let us leave it at that. Normally, they want it worked all the way out. So use that function to form the composite function of. That's all they asked for. However, here in this example, they say what the domain is. They didn't really say the range. Okay, so is there a limit to what I can plug into a squared, adding it with a 5, and then ultimately adding it with a 2? I can't think of anything. I can have positives, I can have negatives, I can have 0, nothing is a problem. So the domain is all real numbers. And then technically, I think the range would be the same. All right, moving on. Example 3. Use the functions f of x is 2 plus sine of x. And I keep losing the problem. G of x equals x minus pi over 2. Find, oh, and then it gave this notation. And a double parenthesis. And state the domain and range. Okay, so this with these multiple parentheses is basically saying the same thing as this is. Pick up G and plug it into F. So that's why they created this other format, because this was the original way to write it, and it just got really confusing with the parentheses and who's, what, where, and they just felt like this was a little simpler to put a circle to indicate, yep, take this second one and plug it into the first one. So that's what we're doing here again. So where F is, we have our 2 plus sine of, and then that's where the x is. So wherever that is, I'm plugging in whatever g was, which is x minus pi over 2. So we have combined it, and I can't simplify that any further other than I could scooch that parenthesis a little closer. So here is inserting it, and now we need to list the domain and range. So the domain would be x is an element of the reals. Is there a such that, or is that all I need? Do I have a limitation? All right, so this is a sine curve. It shifted where I started, but I'm still ultimately getting numbers everywhere because the curve keeps going on and on and on. I changed the center line from 0 to 2, but that's not changing. I'm not still allowed to plug in anything, so nope, I don't have a such that. So my domain is x is an element of the reals. Now, do I have a range? That would be, now technically it would, technically it should be f of x, f of g of x. I'm going to write the y because that's what they did. Y is an element of the reals such that. So this one does have a limit we're going to talk about here. I can live with either the x and the y listed for the domain and range. Doesn't really matter because we all know that y is substituting for the f of g of x, and that's a lot more messy to write than just y, so it's good. All right, now, why in my curvature do I have a limit? Well, in a normal sine curve, if we'd had a height change, it would have adjusted my height. However, picturing the center line at 2, the high point and the low point are normally one thing off. And since I don't have a different change in height, we're adjusting it by that 1. So up here, that's a 3, and down, oops, that's a positive 1, sorry. So I am bounded in my curvature answers to 3 at the top and 1 at the bottom. So that's what I need to write here. So x has to be less than the 3, greater than the 1, and are those included? Yes, I can touch them, so or equal to is allowed, and then close off the answer. So here's the domain and range part. Now, example 4. The function e to the negative 2x plus 1 is a composite function. So that has been created with 2 parts. Use 2 function machines, or find 2 functions basically, to show how it could have been composed. So what does it look like one of my functions might have been? Possibly e to the x. And then what might my other one have been that I substituted in for that exponent? Oh, well, that would have been negative x plus 1. If I put g into f, that's what I get. This inserted up in here, and that's what that was originally. So there are 2 possible solutions for that composite function. I'm looking to see. Yeah, they just wrote it really oddly. Yes, that's totally fine. All right, then example 5. The function of, same thing I just had, is a composite function. Use 3 function machines to show how it could have been composed. Ooh, all right, well, obviously that first one, f of x, is probably still e to the x. G of x is this needs to split into 2 pieces. Okay, I'm thinking, not negative x plus 1, that's exactly the same thing. I feel like I want to split it to something like an x plus 1 and maybe the other one as a negative. In looking at that closely, I realized I left a part off of example 4 that said negative 2x plus 1. I still would have kept that at e to the x, but this would have been negative 2x plus 1. Makes a slight difference. And now if I'm splitting it into 3, I'm going to say that the second function could be negative 2x, and the other one, h of x, could be inserting the x. Oh no, I don't like that either, because I feel like that would be inserting x plus 1, which would distribute with the 2. All right, it does work this way. I just need to picture these flip-flop the other direction. So if I am taking this one, I'm plugging this h into this x, then it's not distributing. It's turning into negative 2x plus 1, which is what we had, and then that is plugging into the e to the x. Okay, so after they got that far with the 3 equations, this problem says we could take another split and separate negative 2 with the x and split it into 4. However, that's getting really complicated. And it said in the calculus book, most of what you will deal with is only splitting it into 2. You can see for obvious reasons why, because it starts to get really easily muddled. So don't expect to have to be doing a lot of this kind of problem. Now, example 6. The function sine of 2x plus 3 is a composite function. Split it into 2 for how it could be composed. All right, in the answer I see they did the domain, but they didn't really ask for the domain. Okay, so one of them could be f of x is sine of x, and the other one could be this part plugged in at 2x plus 3 plugged in here, making the sine. So that's two, very easy to make the composite. Now, the domain of the function, I can plug anything into that. So they're saying the domain is the reals. However, in a sine curve, I do have the boundary just as I had here. The high point would be 1, the low point would be -1, but they didn't ask for that. Example 7, if f of x is root x and g of x is 2x plus 3, find the domain and find the range of doing f of g and the domain of, oh, do it both ways. F of g, g of f. Okay. Just the domain and range, that's what they're looking for. All right, so if I take g and I plug it into f, I'm getting a square root of 2x plus 3. I am bounded by not having negatives come out of my root. So x would be an element of the reals such that, and this would have to be set equal to 0. 2x plus 3 has to be greater than or equal to 0. So 2x is greater than or equal to -3. X is greater than or equal to -3/2. So x has to be greater than or equal to -3/2. All right, I'm looking for their answers here. Okay, the domain of that. Oh, hang on, that is not what they said. I'm going to keep going. Range. What kind of answers can be spit out of this? Y is an element of the reals. And what kind of answers did I say we were going to get? Y will be greater than or equal to 0 because it had to be positive answers. Okay, let's do the other way. Now put f into g. So this is 2 multiplying with the square root of x plus 3. Okay. I'm limited to only being able to plug in positives. So x has to be greater than or equal to 0. And now, is there a limit to what can come out? If positives are going in, I will only have positive answers. Yes. But this plus 3 tells me that my positive answers will be above 3. So y will be greater than or equal to 3. Maybe that was the domain and range for this one that I was looking at here. X is an element of the reals greater than or equal. Oh, it is. Where's the answer to the one before that then? Domain for, oh, f of g contains greater than, yes, the -3/2, yes, and then can't be negative, the range is all real numbers greater than 0. They just didn't bother to write it in simplified format and darken it so that it would be easy to find. But yes, this is the set of answers that they're looking for example 7. Now, example 8. Determine whether the following statement is true or false and why. The other teacher wrote a little note with a star, reread each year. That's interesting. I think she meant for herself, not to the students, but so f of x, let's go to some new space here. Okay, so f of x is x squared, and g of x is root x. I see their point. Okay, so the rest of the statement says f of g and g of f, that their domains are equal. That's what it's asking. Is that true or is that false? So when I plug in g into f, I've got the square root of x being squared, Well, that squared kills the square root and just leaves me whatever I was plugging in. The opposite way gives me the square root of x squared. And again, the squared and the square root cancel off and just leave me the contents of the x. So at first glance, it would appear that they're the same. However, what am I allowed, before it's simplified, what am I allowed to plug into this equation? Only positives. I must remain greater than or equal to 0. What can I plug into this? Anything squared is okay. So there is no limit. I can plug in all reals. So are their domains the same? No, because I have to do it before they're simplified. So it clarifies here that your standardized test that you either took as a junior or are going to repeat as a senior like to use this question because it's tricky. So it says this tricky question often appears on tests, standardized or otherwise, in another form. It involves a statement which appears to be true for all real numbers but turns out to be false when you have negative numbers. That's where I said I had to remain in this format, greater than 0. So it does not work when we plug in the negative. So I guess your answer there is, are they equal? No would be the answer. No, they are not. I was looking for whether it should be no or false, but it's fine.